Hello, everyone. Hope everybody's doing well. So let's start. And we have a hand here. Hold on. Let me see what we. Okay, we're good. All right, excellent. Thank you so much for joining us today. My name is Fred BREEZ. I'm the sales director at EffectiV. Welcome to the launch of BREEZ, our architectural air diffusing ducts, and SelectiV, a powerful selection tool for diffusers and ducts. Before we begin, a big thank you to all of you for taking the time out of your busy schedules to attend this historic launch today. The approximately 45-minute presentation will be followed by a Q&A period. Please write your questions or comments in the chat, and we will try to answer them all at the end if time permits. Without further delay, I will turn over to Frank Godbout, President at EffectiV. Frank, the floor is yours.
Hi, everyone. Thank you for attending our product launch. It's a big day for us today, actually. This is not one small launch. It's two very important product and software that we're launching today. So we're very excited, and we're going to try to compress that in 45 minutes because we do value your time, and we have a lot of other launches coming later this year, and we want you to attend as well. I'm going to share my screen real quick. So before we start presenting the products, I always, at the beginning of my presentations, for those of you who've attended it in the past few years, I always like to take a little step back and remind us, why do HVAC systems exist? Why do we do what we do in our trade? And it's always important to remember the reason why. And this is to create healthy and comfortable rooms for the well-being of occupants. And the room is what matters the most. And that's something we have to remember, because everything else we do is to bring that room to comfort level and the air quality standards that we want to achieve. And you know what we do, EffectiV, we do high performance architectural diffusers. So we are expert and I would say obsessed by efficient air distribution, air mixing. And that's what we're going to tackle today, obviously. So the tools that we have to design a room is, how do we bring the air evenly in the room, no air draft, so that everyone in that room is comfortable. We have good air exchange in the actual occupied space where it matters. And what do you guys have to work with? Tables, manufacturer data tables with throw values, NC, pressure drop. And then you have correct delta T correction factors for your hot air rising, cold air dropping from the ceiling. It's almost impossible to predict the airflow in the room using these tools, because how are you going to apply these throw values and these delta T correction factors to the diffusers in your ceiling, the jet colliding together, the jets colliding with the walls, creating wall jets coming down the walls, the impact of coanda and buoyancy? It's almost impossible to predict. And CFD can do that, but we're talking about hours and days to simulate, and nobody can do that in everyday design. This is why I'm happy to introduce you to SelectiV. SelectiV is our air distribution design software, and this is made for everyday design. So this is not CFD. It's a lot faster, a lot simpler, but it's also very powerful, and it's easy to use. It's fast, and it's very efficient. And you will never see, I hope you will never see room air distribution the same way once you started designing and seeing what you're actually doing in the room. So I won't go over all the features. This is not a training. We have 45 minutes for 2 launches. So I'm just going to give you a few examples of what SelectiV can do, just to give you a quick introduction. And I'm going to go straight to simulation. So this is your room in 3D. We are limited to rectangular rooms right now. We will keep working on the software, making it better, add more features. But right now we have rectangular rooms. In which you can set your operating conditions, your cooling temperature, heating, set point. You can add a door in the roof if you want. You can add a window. The doors are just for visualization purposes, but windows can have an impact. I'll explain it later. More importantly, you want to be able to add your diffusers. So all our diffusers are available in SelectiV. I'm going to use, for instance, our Play S diffuser, which is our adjustable high induction 2x2 diffuser, one of our most popular products. I'm going to set it at 300 CFM. Again, I'm going a little fast. This is not a training, just want to show you the possibilities. And I'm going to add 2 diffusers in the room. You can add it randomly like I did, or you could use coordinates as well. There's different ways. So once you have your diffusers in the room, what you want to do is click on the airflow button here, so you can actually compute the airflow in the room and generate some graphics where you can actually see your air velocity at different point in the room. So this is your view. So we generate it in 2D views, 3 different views. So you have the top view, so you can see your 2 diffusers with the radial jet. The front view, now you can see your diffuser with some jets colliding on the wall, the other jets colliding with the other diffuser's jet entering the space. At the bottom right here, you have your terminal velocity in feet per minute. So here in this example, which is just a random example, we enter at a little bit above 30 feet per minute in cooling. So we could probably try to get a little bit more velocity. But that's how you make sure that you don't create any drafts in the room. And then you can switch between heating and cooling. As you can see in heating, you have the buoyancy factor, so your hot air jet doesn't travel as much. It travels further with Coanda effect, not as much with the buoyancy effect. And then you have the side view as well, so you can switch between the views, between heating and cooling. So this gives you your airflow view in the room for pretty much every diffuser and any condition. I'm going to go back to room design and I'll show you a new example, another example. As you can see, you can save your projects. You can actually create a project for a building and you can generate simulations for each room of the building, save it, go back to it later. We can create different revisions and go back to previous revisions. So the whole back end also is very efficient. But let's focus on the room. I'm going to place another example. I'm going to place in the wall this time our Kobe diffuser here, which is a linear long throw linear slot diffuser. I'll just put one on the wall real quick just to show you the airflow from the sidewall. Here you can see before I do the airflow, you can play with the resolution. So SelectiV is we're trying to get and for very large room, it's not possible, but we're trying to keep every simulation under 2 minutes if possible so that it's fast. But for large rooms, you could change the resolution to very low and the render will be extremely fast, as you can see, but the resolution is not very good. If I go back and I change it to, let's say, the second highest, it's going to take a bit more time. Some diffusers take more time than others. This one usually, I think it's probably going to take about maybe 50 seconds in total. So when we compute the airflow, what do we do exactly? Again, this is not CFD. CFD will take hours to do. We take manufacturer data from the diffuser. We apply it in the room. We manage all the collision jets together. We apply Coanda effect, buoyancy factor, and any other ASHRAE standard and scientific factors that might apply. Here you can see your cold air jet falling in the room. It's leaving horizontal, hits the floor, creates a wall jet up. And in heating, your hot air jet rises and hits the floor and creates a small floor jet. How can you actually even evaluate that with manufacturer data table? Without that tool, it's very difficult. All the correction factors are applied for you. We also have a 3D view. So 3D is actually, we don't compute airflow in 3D because it would take too much time. We do the 2D views and then we recreate a 3D extrapolation. So it's just a preview of your room in 3D, but that's actually pretty amazing. It helps you visualize the airflow in the room. If you don't understand the 2D views, sometimes it's a good way to take a step back. Okay, oh, that's how it looks like in 3D. And then I'm going to go back to my 2D views and okay, now I get what's the front view or the side view. So that's another tool that we have in SelectiV. One last example, which I think is pretty nice example to show you. We're going to make not too big because we're in real time. I need to render in real time so I can go with very large room. We can do rooms 400 feet by 400 feet by 200 feet high. We can do very large rooms in SelectiV. So I'm going to go here 60 by 40 by 30 feet high room. And in this case, I'm going to use a matrix of diffusers, okay? And I'll show you a really cool feature. So let's do open ceiling, and we'll install the diffusers at 22 feet high in a 30-foot high ceiling. As you know, what's very difficult if you deal with heating and cooling, it's to get that hot air down. You saw it with the Kobe, right? The hot air is going to tend to rise real quick, create stratification, and then we lose a lot of efficiency. We waste a lot of energy in heating. Sometimes we don't even change the air in the actual occupied space. In this case, we're going to use, if you're not familiar with our thermodynamic diffusers, this is what they do. They switch automatically between heating and cooling to send the hot air down and the cold air along the ceiling so that we don't need any destratification fans and we get perfect airflow in both modes. So I'm going to select the AX6 active model here, okay? And as you can see here, I'm going to leave the size automatic. And I'm going to set the room at, let's say, 3000 CFM for the room. And there's an auto design button here. So what it does, it's going to analyze all the possibilities for you and give you the perfect or almost perfect design or the most optimal design. Sometimes perfection doesn't exist in some rooms, but it will analyze all the dimensions, all the number of diffusers, location, diameters, and give you the best option. So everything in our range is what you set, and it's going to set everything in green. I'm going to click on it now. And analyze about 800 possibilities. Sometimes it can be longer. And it said, okay, for your application, we're going to use a 10-inch neck size with 2x2 diffusers. I'm going to apply that in my room. This is my matrix of diffusers. So, and it can be applied to larger room as well. Now we're going to click on airflow. This is your airflow in cooling. Have the front and the side view. Looks pretty good. We enter at about 50 FPM. And in heating, this is your thermodynamic diffuser. It switches to shoot the hot air downwards. And we enter here slightly above 50 feet per minute in the occupied space. In heating, not too bad, 55 feet per minute. And then you actually hit the floor and you cover pretty much the whole space with your hot air. Very efficient. Thermodynamic diffusers, if you're not used to it, it's a no-brainer. Anytime you have 16 foot and higher ceiling, thermodynamic diffusers are the way to go if you do heating and cooling, obviously. So, and in 3D gives you a pretty good idea also of your airflow in the room. See how we actually cover the occupied space very well. So I shouldn't go too fast. I know that in Teams it's probably laggy. And in cooling, well, we have the cold air across the ceiling that reaches the floor more slowly. So to give you an idea, I can do that actually. Let's go back to our matrix. And if we didn't have thermodynamic diffusers, I'm going to use the manual adjustment diffuser. I'm going to keep the same location and number of diffusers, 10-inch deck, and I'm going to manually choose the horizontal mode. So that's what people normally do. They'll put diffusers horizontally along below the ceiling or in the ceiling. The cold air is going to come in nice, but in heating, the hot air, this is what it's going to do. And SelectiV, it does that. It helps you find the best solution, validate it, but sometimes it helps you validate what doesn't work also. And in this case, this is what happens. If you do CFD in your room, that's what you're going to see. Or if you test it in our test lab, you're going to see that hot air go up and stratify the ceiling. We're not heating the space. We're not doing any air changes in the occupied space. This is very inefficient air distribution, and we see that all the time. People end up putting fans to push the hot air down. So it gives you a good idea of, how you can work with SelectiV to test different scenarios as well. These were the 3 examples for SelectiV. I see a lot of questions. Thank you very much. I can't read them as I speak, but we're going to answer them later. Before we move forward with the second launch, I'd like to get your first initial feedback about SelectiV. What are your initial thoughts? What do you think about it? It's always good to get your first impression. This is the first time that we show it publicly. So we'll take a minute and please add it in the chat if possible. Fred, do you have any comment or any question I should ask in the meantime, or you want to keep them all for the end?
At this point, it's pretty cool. There's a couple of things I think will be answered as we move along in your presentation, so I'll keep the rest for the end.
Okay, perfect. Do we have any comments coming in?
Comments are slow. It looks impressive. Thank you, Rob. Appreciate
I'll take that.
Yeah. Very useful. Very helpful. Thank you. Keep them coming. It's much appreciated. Like, we're making this for you guys, so your comments are so valuable.
Great. Give it another 10, 20 seconds. People might be typing, and then we will share our second launch, which some of you might be familiar with. BREEZ are architectural duct diffusers. Now we have people from Canada, we have people from the US here in the room. I know this is Eastern Canada is more familiar with these products a little bit. People in the US probably haven't seen a lot of these. They are very popular with architects to begin with. They are 5 feet long duct sections. It's not spiral duct. It's rolled and welded on top, powder coated to the architectural's liking, comes with all the duct fittings, etc. And then we use perforations to diffuse the air. The difference that our BREEZ has compared to other products out there, including fabric duct, if you want to compare it to that, is that we do have the circular holes, but we have 4 different hole patterns. So why stop at circles if we can also make cooler shapes like rectangles, half moons, and arrows? There's a 5th pattern coming up soon as well. So that's one way to differentiate. But how do you make it a high performance architectural duct? You know, these are different holes. The air coming through it there's no device in there, anything special. It's how you actually select that performance. So these are the different hole patterns. You can, in the software, that's obviously we're going to do it through SelectiV. You have 4 different arrow patterns, 15 different hole diameters, different half moon and rectangle. So we have a pre-selected number of patterns to cover the whole range of applications. And we've done quite a few projects with it so far. We can cover pretty much anything. And how do you do the performance? Well, you guessed it. In SelectiV. Let me show you how you can build a duct line. Let's make our room a little bit bigger again. 60 by 40 by 30 feet high. Okay. I'm going to add a window again. And this time, the doors do not change anything in SelectiV. And it's important to explain, when I said we use manufacturer data, there's no heat exchange between the walls and the windows. And if we did that, now we would get into CFD, and now you would have to wait for hours for your results, maybe, or a long time at least. And you would have to input all the information, the U factor for the windows, the external temperature. It would take a lot longer to prepare and run. So we kept it day-to-day use, so that you don't use manufacturer data table anymore, and you don't have to guess your room air distribution anymore. So in this case, there's no heat transfer. It's about air velocity and where the air actually reaches in heating and cooling. However, the windows can be used. You saw the auto design with the diffusers earlier. If there had been a window in that room, it would have moved the diffusers towards the window. So you'll see later what I mean. So let's start by building a duct branch. So I'm going to start the duct. It can start from the wall, the ceiling, anywhere in the room. I'm just going to start from the wall here. Oops, sorry. start from the wall here. Okay, and you could actually build a duct line. Let's say I'm going to use a shortcut to go faster, but you can do some splits and you can build your duct line very quickly. You could create a BREEZ here and then just copy your duct and your line. You see the how fast it can go actually. If I put another elbow here, and let's say you made a mistake, you could change the angle, the direction of your elbow. You can go up or down in the room if you want. You can have different angles, 45-degree, any angles. You can do anything with the ducts. You have reducers, dampers, everything. But for the purpose of the example, rendering the duct through all these little perforations takes more time than one diffuser. So I'm going to make a very simple run for you today, so that we can run it in less than 5 minutes even. So I'm going to create a BREEZ section and create a full duct line here. Okay, so I created a group of sections, and you don't see any perforations on the duct because we have only one row. I created a BREEZ. I'm going to move it at 90 degrees. See, now you see your little holes. You can change the size to larger holes. You can change the number of holes. So every duct is a combination of how many rows, the angle of every row. So I could add another row with arrows at 110-degree rotation angle. Oh, it's too close from the other one. There you go. Now we have them. So you can do anything you want, and you can see actually your patterns on the duct in real time in 3D. That's pretty cool. So the problem with that is that now you have the tool to sim, and obviously you're going to get the performance later. You have the tool to simulate the performance and view the airflow. But to design, even with the perfect tool, to design a duct, there's so many possibilities of how many rows, what angle, how many holes, what size. It could take a day to design not even the perfect design, but to get to something that works pretty well. This is why we created the auto design feature. So I'm going to make our duct 1000 CFM, round numbers. You can actually click the validate button to validate it against all SMACNA rules or recommendations. So let's say you don't have an active section right after an elbow, duct size, etc. And then you can run auto design. And this is the magic of BREEZ with SelectiV, is that auto design will evaluate every possibility of how many rows, the angle, the hole size, how many holes for each row separately. And I'm going to choose the pattern circular here. And I'm going to run auto design directly. This one takes a little bit more time. So it's going to go through a lot of different possibilities. Also, I mentioned that we were close to the window. So it's going to try to cover the window more than the rest of the room. Hopefully it works well in this example. The algorithm is very advanced. We're going through thousands of templates possible, and then we add rows, remove rows to these templates and move the rows. Then we said that we can simulate hundreds of thousands, sometimes millions of possibilities when you have a more complex ducts of for each row, how many holes and everything I already said. Then we take the 2000 more better options. This is isothermal quick score with an algorithm. Then we take the 2000 best options. This is what you see now. For these 2000, we do actual heating and cooling, accurate simulations, but very fast. Every square foot, we analyze the airflow to try to find the best ones in terms of entering the occupied space and covering the window, etc. And then we take the 200 best options, and then we do a final run for the best 200 options with a finer mesh of every square inch in the room. And this is how we're going to pick the best top 10 options with a score for you automatically. So the work that would take a day to probably not even find the best possible option This one's going to give you your top 10 best and 3 alternatives as well. In the time it took me to explain this, we're almost done now, so I would say probably less than 2-3 minutes. Listen, we've done rooms with 8 ducts that are super big with angles, and it might take half an hour. You go for lunch, but it's done automatically at the end. So here you have your scores in cooling and heating. You have your top 10 options with different scores, your 3 alternatives. So let's just try the first option here. So we have 11 rows on our duct. Before we render the airflow, look at your hole patterns. This is how it looks like. Oops, I'm sorry. This one, sometimes it's hard to get the view from the hose from close, but you can see it's a bunch of different rows with a little bit more on this side. A lot of small hose. You have a preview button here where you can actually preview your airflow before you actually run the simulation. That's super fast. It gives you a quick preview in 3D. That's useful when you want to fine tune let's say you want to remove some rows of hose or change something. This gives you a quick way to work without running the simulation every time. But that's an approximation, right? The jets don't spread. The throw is not fully, it's a quick simulation, a quick approximation for a 40 FPM terminal velocity. If you're happy with it, this is when you run your simulation. This one's going to take a little bit more time. Nice, I see some nice comments coming through. This one's going to take a little bit more time because we optimize it. We try to not replicate, but how airflow is, so a diffuser is CFM and we have manufacturer data, right? The duct is different. We calculate the static pressure all along the duct, actually in even 5 segments per 5-foot section. So every foot along the duct, we recalculate the pressure evolution, the total pressure, static pressure, velocity pressure, including elbows, fittings. You can have multiple branches, and then the size of the perforations on every branch is going to affect every other branch. So if I have 2 branches and I change one hole, you're going to see the airflow change everywhere in the duct. Once we know our pressure everywhere along the duct, we're able to calculate our CFM for each perforation. Once you know your CFM for each perforation and your pressure, your available pressure, you can calculate your throw. Okay. Now that's one small jet. The jets, the closer they are, each jet is going to spread, right? And the closer they are, jets will merge together, and then it creates kind of a linear jet. And so that changes the throw. It's going to deplete slower, and it's going to travel further. Same thing, if you have 2 rows, and let's say if you have a very small diameter, your rows can be at a large angle, your jets are never going to collide together. But if they are in a similar angle and the jets spread more, the rows spread faster than they diverge, they're going to merge and create even a larger jet that will travel further. SelectiV takes every single one of these things into account. Extreme calculations, it takes a while, and then it's going to apply buoyancy and co-on, like I said before. And here's your airflow. Let's go to top view. This is your airflow in cooling from the top. And in the front view, it's actually the side of the duct, but it's the front view. You can see your air jet. So now we enter the space at about 45 feet per minute, I would say, something like that in cooling. And in heating, we're in the 40 FPM, maybe 36 FPM, I would say. Yeah, something like that. So good air velocity here. Let's look from the side view. This is the beauty. See how BREEZ actually automatically came up with a pattern to cover your whole windowed wall. Again, we're not doing the heat transfer, but we're covering it. We're blocking the heat gain or heat loss, focusing more air in the window, and yet covering the whole room with perfect velocity in heating and in cooling. So you can see your buoyancy effect with BREEZ. It's pretty much a perfect airflow, I would say, for something like that. Doesn't end there. Once you're satisfied and you want to get a report that you can send to your client, if you're a distributor, send to the engineer, or maybe just for your archives, you can click on report here. And in one click, you just sit back, have a little sip of water, and you let SelectiV generate a complete report for you, including the duct geometry, dimensional drawings, all the pressure calculations, performance, including performance data. Well, I didn't enter any project details, but you would have the project name, engineering firm, building type, etc. This is your room dimension, total CFM, occupation height, one duct line, max target 35, cooling, heating mode, conditions, your room configuration, quick perspective. This is your duct schedule with you might have multiple ducts. They all have a different tag. Same thing. By the way, this report works for diffusers as well. If you have a bunch of diffusers, they all have a tag. This is your schedule. And then you have for diffusers, you would have all your tags and every diffuser will have its performance. Here we have one duct. So this is your where it starts, the location, 1000 CFM, your static pressure, inlet static pressure, total pressure, max NC. So the maximum NC generated by all the perforations is NC 20. So that's the worst perforation on the whole duct line. It generates noise that's NC 20. And this is your duct length. We have something else that's perceived NC. Well, our NC is pretty low right now, but what's the difference between NC and perceived NC? For ducts that are usually in higher ceilings, large open spaces, or even thermodynamic diffusers earlier, yes, they might generate NC, let's say NC 30, and you wanted to achieve NC 25, let's say. And now you see NC 30, and like, oh, it's too loud. Where is it in the room? If it's at the ceiling 30 feet high, you're not hearing that NC 30. Perceived NC, that's what it does. It's based on ASHRAE Fundamentals, Chapter 8. We have all the calculations here, and it takes into consideration the noise generated by each diffuser or duct, even the air inside the duct in this case, actually, the installation height, room attenuation, and it tells you if you stand in the center of the room, 5 foot high, this is your perceived NC. And in this case, we went from 20 to 11. So your earlier, the example NC 30 might actually be 24. And you might get the correct NC for your perfect performance. So that's another benefit of SelectiV. We can actually calculate that automatically for every diffuser. Very important. This is the NC that actually matters, in other words. This is your perforation details. This is your duct layout. So you have every component with a tag. So you have the tag for the duct, and then for every component, you have your passive sections, your active sections. For every active section here, let me zoom in a little bit for those of you. For your active section, you have, so it's a 20-inch diameter, 60-inch long, 1000 CFM is at the entrance. We're diffusing 111 CFM from that section, and C20, this is your tag, and this is your magic recipe. Your hole pattern, your degree, the position of the row, and the number of holes. So this one's pretty symmetrical. It's just the angle that changes. And this is your complete recipe for the duct. That's what we use to produce the duct after automatically, actually, with the perfect perforations. As you design them, it goes straight to CNC laser cutting with that pattern. No possible error. So here's your overall performance. And that's one thing that when we first present, because we've been, by the way, we did some pre-launch with a few distributors in the local market. We've done many projects already with the BREEZ. This is new officially, but we've been working for it for a long time. And at first, everybody were challenging us on the static pressure. It's like, Frank, it's impossible. You can't have 0.066 inches of water static pressure. It doesn't work. It's got to be half an inch. It's always been half an inch. You're not going to be able to shoot the air far enough. So we went back to calculations. We revalidated everything. We researched again all the papers, and we even did some tests. And these numbers are right. The problem, and then the question was like, but why do you say it should be half an inch? And we realized quickly that this is common knowledge that comes from fabric duct, which is what people have been using the most, more than metal ducts. And fabric duct, they require more static pressure to keep them inflated. Sometimes they're more porous, so there might be some static pressure loss there. And even the holes, each perforation doesn't have a sharp edge like metal, and that can make a 20% difference on static pressure just to shoot the air at the same distance, having a sharper edge like laser cut metal versus fabric. All that together, it makes a big difference. So we go from 1/2 inch static pressure down to 0.066. That's a fraction. It's what, like it's a little bit more than, let's say, 12%, 15%. So that means that you can use smaller fans. You don't need high static pressure fans. If you design for 1/2 inch and you need less, you're going to be outside of your high performance curve. So now you can design inside the performance curve with cheaper fans. You might save on energy even. So it becomes a sustainable product even, and you might actually save money on your equipment by investing more into nice architectural duct diffusers versus fabric duct, for instance. We also, for that reason, we actually give you the complete calculations of your static pressure here so you can actually see for each section what's your velocity pressure, static pressure, total pressure, the friction. Now we don't have fittings, but elbows, splits, everything it's calculated, the friction there, the static pressure regain when you diffuse the air, and you have your required duct inlet static pressure. The worst case is this one, 0.659, and that's your governing section. That's how we calculate static pressure. So we are transparent about everything in SelectiV. We do all the calculations. We don't invent them. It's all scientific data, and then we give you the calculations here. We even added a 20% safety factor. You can see it here on the static regain, just in case to be safe, and 15% safety factor on the pressure loss for fittings and everything, just to be on the safer side. So when we give you that, it already includes a lot of safety factors. Moving forward with the report, we're getting close to the 45 minutes. Now you have your performance. So these are the views that we had earlier in cooling, in heating. It's all automatic. And last but not least, now we only have the BREEZ, but if you had 10 different diffusers in there, you would have your 3-part specification for every diffuser or duct that's included in the report, which you can easily copy and paste. But in SelectiV, you can also go to your project and export a Excel file with your BOM, bill of materials, and then you'll have the specification as a text file that you can copy more easily as well. I can go into all the features, but we made everything possible convenient for engineers in their design. So, and then the last one is this a disclaimer. It's pretty cool, but it's not CFD. So we don't take into consideration heat transfer, location of the returns, anything like that. But we consider everything that's in the manufacturer data labels and scientifically known and more. So going back to here, I think I covered pretty much. Let me just show, if I go back, this is your 3D view of the airflow as well, available with ducts. You can switch between heating and cooling. And I'm going to load, I showed you the split earlier, just to give you an idea of this one here. This is what I was going to design. I will have taken twice the time to render and everything, and auto design would have taken twice the time, but I'm not going to run the dirty inflow, but just with the quick preview, you see how the same duct with 2 branches, this is what auto design did. So that branch covered the window more and part of the room, and the other branch covered the rest of the room here. Obviously, that's, the preview. We reached the floor and everything. It was like a kind of perfect airflow. So we can run it on multiple branches and ducts as well. I think I covered everything. Before I answer questions, I've seen a lot of comments go by real quick, but maybe take 1 minute to answer your questions about, before we answer a question, get your comments, your first impression about BREEZ in particular, BREEZ combined with the performance. Would like to hear your thoughts, what you think about it.
And while you're thinking and while you're writing down your comments, and we appreciate every single one of them, want to reinstate the fact that today is a launch. It's not a training. And I think, Frank, you went through most of it, but the training will come pretty soon as well. We'll explain you how we're going to process with that. And There's a lot of questions, Frank.
Nice.
Good, very good questions as well.
Bring it on.
I apologize in advance. We might not have the time to go through all of the questions, but I'll try to regroup a few of them as we go on. And while you're all putting more nice, very nice comments, we really appreciate that. So one of the comment that came a couple of times, it's probably due to we went through validate a little faster. The question around that is more like, can we validate if we have the right duct size, if we need dampers, if we need balancing, and all of that. So I'll let you
It
answer
does
on
all
this.
that. The validate option will, let's say if you had a 20 sections long of is going to say, hey, you should insert a reducer or a damper here. Let you choose it and can do it automatically for you. Suggest some diameters, correction, and everything. We go through all this MACNA requirements or suggestions, and we apply it in there, including maybe some extra ones that we come up with. Yes, that's what the validate does. So usually you would do validate first. For a single duct run short like this, there was no purpose. But if we did a complex duct, we could have run through it and it would have made suggestions. So you would do validate, and then you would do auto design after once you validated everything. Yeah.
Excellent. One other question was, is there any options for internal insulations?
Not currently, no. But it's something internal, external, obviously would be a little complicated. Internal is something we are looking into. It's not a standard, but let's say with some closed cell insulation, if we're talking about acoustical insulation, there's something that we could do. But that depends on the perforations also. You know, obviously, if you have a very wide spread, if you have perforations on 60% of the duct, you're only going to do acoustical insulation on the other 40%. So, you know, that's why it's a little bit difficult. It depends on your pattern and design, really. So case by case for now. Reach out to us if you need it and you have a specific project.
You're talking directly to the manufacturer in this case, so that's good. The one of the other question, like, we understand that the maximum length of each section is 5 foot, right?
Yep.
So is there a way to have a smaller section if we need to, and but we're not going to go over that 5 feet section dimension?
Yeah, you can do 1 to 5 feet sections. To give you an idea, here I could go and let's say this one here, I could change it to let's say 3 feet, 36 inches. Boom, your duct moved, everything moved, and now you have a 3 foot section here.
While you're there, can you move the entire duct, like from the wall? Like let's say I want to move it like a foot away on the left side.
Select your start,
possible?
and this is your location. Let's say on the width, I want to move it to 12 feet instead of 17. Boom, now we're closer to the wall. So you can move it like that easily. You could change, like I said earlier, you can have like a angles. You can do anything. It's just you can do 1 to 30 degrees. So I can do a 10-degree angle. There you go. Well, it's now we're outside the room. It's flagged. So you can really reconstruct your duct as much as you want. Let me show you another example here. If I have I want to add a damper to this section. Okay. It might be easier if I go back to 90 degree to see, and I'm going to come from the end. So here I added a damper, and now it's fully open. Let me mess with the damper a little bit. You see airflow? Every pressure is recalculated everywhere along your duct, and your airflow is impacted based on how you play with the damper on one side. So same thing with reducers. Yeah. And you could delete one branch, add a new fitting. We made it very user-friendly to build your duct. Actually, the whole software, now you see me play with it, but once you use it, you'll see a lot of emphasis was put on performance and data and scientific data, airflow, but also a lot of emphasis was on user-friendly because we want you to use it and find it fun to use. Not just useful, but it's even, people enjoy it, actually. It's fun to use.
So even me, not being an engineer, I can play with this and accomplish a few things.
You know the answer, Fred.
All right, that was not a real question. All right, let's keep track on the questions. There's a couple more.
And you're
A
getting
couple
pretty
more.
good at it too.
Yeah, we're good. All right, thank you. I'm going to read them as they come in. And again, sorry if I missed one or two, but um, they seem to hang in the air, like there's nothing holding them right now.
They float with
Those
helium.
ducts.
No.
They flow with helium, eh? All right. So you diffuse the helium and you recoup the helium and you're in the
Yeah.
ground. All right. So let's
There's different mounting systems that we have, and soon now we wanted to do the launch. We're gonna add it on the website in the next maybe tomorrow or early next week. You'll have all the data sheets and the submittals, but you can have you can have rails in which they attach and they're easier to install. The rails can be suspended from the ceiling with threaded rod, and we can cover. We can provide rod. We don't provide the threaded rods, pretty standard, but we can even provide the rod cover painted in the same color as the rail and the duct. You can have wall mounting brackets, direct ceiling mounting brackets. There's different options. We have options for every need, really. And I will answer a question that I saw pass by real quick because it tackles into this. We offer any color possible, any RAL color possible, preferably. That's super fast, but we can match other colors if we need. So anything the architect wants, we can do. Sometimes the cost might vary based on some colors, but there's no limit. We can do even metallic, neon, anything. So
and
it's all
different finishes as well in terms
yeah,
of
it's all made and powder coated in Canada. We can powder coat the inside if we do some. We've done some pool projects. It's galvanized steel, so there's some rust protection, but they ask us to powder coat both the inside and the outside to be safer on the rust side. That's an option that's possible with an extra cost. Um, so yeah,
so
I'll
I
let
think
you
you
go with the
just
questions. Yeah,
no, I think
answered
you
a
just
few.
answered you
Okay.
just answered another one as well, talking about galvanized steel. That's the option that we have at this point. Um, I have another question. I'm going to paraphrase it. If we had VAV systems that would need a calculation at full speed and then run one more at minimum speed to see the effect, I guess that's the intent here.
Yeah, you could actually even have you could do it in two different velocities and compare. And sometimes we see a lower airflow in heating. Instead of doing two simulations, you could say, okay, in heating, I run at 60% of the CFM in cooling. You could have that in your configuration. And auto design for diffusers or ducts would take that into consideration to try to find the most optimal airflow or combination for that. But it doesn't do, let's say, VAV in cooling. You're going to have to do one CFM and then another one if that's the case. But you could do that, yeah.
A question that regards SelectiV. Can I take into account return locations and number?
No returns selected, taken into account.
Point.
That would, yeah, we're getting closer to CFD in this case because it's not the direct impact of the diffuser, it's the whole room circulation after that.
Yeah, so that makes a distinction between the manufactured data and the corrections versus a full CFD that we also offer as well, right?
Yeah, we have the verified service. We've been offering it for years. It's kind of a, let's say once you've done already your design and you want to validate one room in CFD, we can just extract the data from the room from SelectiV, and we're just gonna have some extra questions for room installation, window installation, but it even expedites the CFD service, makes it faster, more efficient for if you want to spot check some more specific applications, and that will include the placement of the returns. Yes, with CFD.
So one other question that comes around in the chat is, this is pretty cool. How can we collaborate as a team? Can we save this? Can we go back to this? Can we make revisions? Did we think about that?
Yes, it's everything. I don't know if I want to go into my projects because we do a lot of silly tests, but on the other hand, but yes, actually, if you click on projects, you will view a lot of different projects. All your projects, you can share it with other people, so they can view your projects. Your project are yours until you share them, then they can view and modify it. But every time someone modifies it, it creates a new revision with, and you know who modified it. So it does all this for you. It's collaborative also in the back end. And if you have once you start using it, you have ideas, suggestions, we can keep improving it. But it's we have two distributors have been using it for months now, and they seem to love the collaboration tools as well. Yeah.
Let's talk about the support that we offer as well. Like we understand that maybe for a simple application, once you're trained, that you work with the with SelectiV, you're pretty familiar how to work. What type of support we're going to add or we're going to have to support the, I would say, more extensive or complicated designs?
Yeah, I mean, you still get the what we call the effective experience, and I know some of you have experienced it before, but the effective experience is still there. It's just that you can do on your day-to-day tasks, you can achieve a lot more with just SelectiV without us. Every time you're not sure about how to approach something, it's more complex. You contact our distributor, our local distributor, depending on where you are. If it's too complex, we'll hop on the call with them and we'll work with you. If you don't have a distributor, we'll help you directly. But I think that's one of our strengths, the expertise and availability that we offer for support like that. We'll hop in the teams, go into SelectiV and present some options, and it's part of what we love, actually, these challenging new rooms we've never seen and new challenges. And if there's no good option, we'll tell you if we don't have a good option. But more often than not, we do find solutions that work pretty well. So
Where maybe others have difficulties to find other solutions. That's the strength of EffectiV and the software at this point as well, and the expertise that we have here. So my camera just went off. Let me go back in here. Let's go. So a couple of more questions, quickly. There's a couple minutes left in the meeting, and again, thank you for the participation. You're phenomenal, guys. It's great. We should do this more, right, Frank? Well, I think
we should.
there's
We
more
should.
webinars coming up, right?
Before you ask more questions, in case some people need to leave, and we can answer the other questions if you guys can stay. In the chat, you should put the link selective.design, if not already done. So there's no
I'm gonna do
.com.
that.
It's https selective.design if you haven't seen it on my screen yet. And you click on login, register, and then you will be pending obviously the software. We're not selling it. It's a free tool for all engineers and distributors, but it comes with a training. So we're gonna go by groups. It's gonna start in the next few weeks, and there's gonna be different schedules. You join the training, and we want to train people. We really want to make sure that you use the tool to its full potential, and also we're going to give you tips to be faster. So I think it's very important. And as soon as you go through the training, you'll have access to the software at the end of the training forever. So that's very important. And then you can ask more questions, Fred.
Yeah, that's great. And again, I think we talked about that we can paint the inside for full protection for swimming pools. I think we covered that as well. Tell me if I'm wrong, of course.
Yep.
Is there a metric or imperial option
Some products have a metric in there, but most of it is really imperial right now. And we might add metric down the road, but then we've experienced it with a previous software. When you start messing with conversions, this is where a lot of bugs happen. I saw a question pop up about in the first part about, is there bugs or things that prevent from using the software earlier in the meeting? It's very stable now. I'm not saying you won't find one bug ever, but it's been tested for a while. It's very stable.
It's been
works
months
very
of
well.
testing. Yes,
Yeah.
yes.
Oh yeah.
Yes.
It's been
Yeah. All right. Of course,
Thank you.
the smaller section to complete a line, we said that can be anything between 1 foot to 5 foot. We can do
Yeah.
like 31 inches if we need to, right?
Can do 31.82 inches if you want, but the minimum
Perfect.
is 12 inches because we use sleeves to join ducts together with gasket, respecting SMACNA again, and so for air leakage, and so that because of that, there's I think the minimum section is 12 inches.
Okay.
The length.
Or we
That's
can
it.
have two smaller sections, you know, to make it look a bit more even and nice,
Yeah, but if you need
architecturally
a
speaking.
4-inch section, that's all we can do. But usually on the dock, you're going to play on the other sizes. Yeah, that's the only limitation. 1 to 5 feet, and we can do any size.
Can
And
you
the
have
diameters, the
Yeah, go ahead.
diameters
Yes,
start at
thank you.
8-inch diameter, all the way up to 60-inch diameter.
Ooh, okay.
So we can do big ducts with these as well. So we do a lot of large ice rinks in Montreal, pools, indoor pools, convention centers, these kind of large spaces as well. But we also do a lot of school gyms and small offices, sometimes open area with a nice small duct. So it's a lot of
Frank,
applications. Yeah.
Frank, we're coming to the end.
Okay.
It's 1 o'clock right now. Everybody stayed, and most of everybody stayed. So thank
Thank
you
you.
so much again. Much
Yeah.
appreciated. We will follow up with you with the recordings and further information through your distributors. All the distributors present that invited their clients and guest engineers. Thank you very much for your support as well. And we'll let you go. We'll wish you a good rest of day, a good weekend ahead, and enjoy this fabulous summer that we're having right now. So thank you very much, everybody.
Thank you, everyone. Have a wonderful day.